So for number 78, we want to find out whether the sequence is increasing, decreasing, or not monotonic. So not monotonic just means that it's alternating between increasing and decreasing. So we have that an is equal to n plus 1 over n. And what we're going to do here is we're going to look at whether it's increasing or decreasing through the function y is equal to x plus 1 over x. And the reason that I can do this is because the function and the sequence, they have the same behavior, right? They go to the same place. They both either are increasing or either are decreasing. You know, the only difference between them is that the function is defined for all the real numbers, whereas the sequence is only defined for the natural numbers, but they behave the same way. So we're going to take the function, and the reason that we're using the function is because with the function, we can use the first derivative test, right? So the first derivative test basically tells us to take the derivative because the derivative is the rate of change. So if the rate of change is positive, it means that we are increasing, right? If the rate of change is negative, it means that we're growing negatively, so we are decreasing. So we're going to take our y prime, which is the derivative of x is 1, and the derivative of 1 over x is going to be negative 1 over x squared. And so we're using the function because we can differentiate it. We can't really differentiate a sequence. And so we're just going to clean this up a little bit. Actually, we're going to join it so that it's easier for us to analyze. So if we join it, that's going to be x squared over x squared. So x squared minus 1 over x squared. Okay, and now we're asking ourselves, when is this derivative going to be positive and when is it going to be negative? So the bottom is always going to be positive, right? It's absolutely always going to be positive because it's x squared. So it doesn't matter if I put like x is equal to minus 5, x squared is going to be 25, so always positive. And so what we're really asking ourselves is, when is the numerator going to be negative, right? When is it going to be negative? And so what we're going to do here is just say, okay, x squared minus 1. Let's think about how this looks like. So you could do it through the critical points, which I've done in the previous examples, and I'm just going to make it maybe in a little bit a more fun way. So x squared minus 1 is a function that begins at negative 1, and then it goes upwards like this, right? And we know that the roots x squared minus 1 is equal to 0 when x is equal to 1, right? So 1 squared minus 1 is equal to 0, or when x is equal to negative 1. Negative 1 squared is 1, minus 1, 0. Okay, so these points here are x is equal to 1 and x is equal to negative, oops, I should put this, x is equal to negative 1. You can do this using the critical points, right? But since I've already done that, I'm just going to show a different perspective, a graphical perspective. So we can see here that the top, it's going to be positive whenever, so y prime is going to be positive whenever x is either greater than 1, right? Because if x is greater than 1, we're going to be over here where all of this stuff is above the x-axis. So when x is greater than 1, or when x is less than negative 1, right? If we go from to this direction to the negative x, we can see that everything above is going to be positive. So we can say that y is positive when x is less than negative 1. And when x is between 1 and negative 1, it would be in this situation here, we can see that when it's between 1 and negative 1, then it's going to be negative, right? Then our derivative is going to be negative because this output is going to be negative. So we can say that y prime is going to be less than 0 when x is between these two values. So when this happens, what we're going to do here is we're going to say, okay, what about our sequence? In which scenario does our sequence fit in? So our sequence, we're never going to evaluate it at less than negative 1, right? Because our sequence begins at 1, 2, 3, 4, 5, and so on. So this can't ever be. what about this situation here, when x is less than 1 but greater than -1? Well, it can't also be, because our sequence, it begins at 1, so it goes 1, 2, 3, 4, and so on. So it can't be ever less than -1. So this we also cancel out. And so the only possibility for us is when n is greater than 1, right? And we can see here that when n is greater than 1, the derivative is going to be positive, and so our sequence is going to be increasing. And so we can say here that we can say that n is going to be always greater than or equal to 1, right? It's never going to be less than 1, and so the derivative is always going to be positive, so an is always increasing. An is always increasing, right? And so let me remove all of this. So we can say that an is increasing for n is greater than 1, so an is monotonic. Okay, and now it's asking us, is the sequence bounded? Well, the first thing that we have to look at is that if an is increasing, it means that the smallest value is the first one, right? Because a2 is going to be bigger than a1, a3 is going to be bigger than a2, and so on. And so let's check a1. a1 is going to be 1 plus 1 over 1 is equal to 2. So it means that an is always going to be greater than or equal to 2, right? Because every single term afterwards gets bigger and bigger. And so the smallest possible value is going to be 2. What about the biggest possible value? Well, since it's getting bigger and bigger and bigger, we need to take the limit as n goes to infinity, right? Because it increases as n increases as well. So we're going to take the limit as n approaches infinity of n plus 1 over n and see what happens here. And so we can see when we take this limit that we're going to have infinity plus 1 over infinity, which is 0, right? Which is just infinity. And so an is always going to be less than, not equal because you can't be equal infinity, but less than infinity, right? And so it's not bounded because even though it's bounded below, it's not bounded above. It doesn't have a limit above, right? So we say that an is only bounded below. So not really bounded, because when we say bounded, it means that it has a bound above and a bound below. And that is it for number 78.